learners, this is Education Online program. This is chemistry and our topic is the physical properties of period 3. So this lesson is for senior 3 and 4 and I'm teacher Lily going to present for you. So what is this physical property? What are the physical properties of period 3? As we know that period 3, their elements are similar to each other and they have some properties which are almost the same through the period. So we know there are 8 elements in period 3, which start with sodium, magnesium, aluminium up to argon. So here the first physical properties will be the physical appearance of these elements in period 3. So physical appearance. Physical appearance. So physical appearance here, the elements of period 3, they vary in their appearance, showing metallic and non-metallic properties. So it means here we know that sodium, magnesium, and aluminium, they are all known as metallic elements. So metallic elements are 3 in this period. We have sodium, magnesium, and aluminium. Then the one which is in between is silicon. Silicon is behaving as non-metal and a metal at the same time. So it has metallic and non-metallic properties at the same time. So the other 4 elements, which is sulfur. First of all, we have phosphorus, sulfur, and chlorine are non-metals. So the last one, which is argon, is an inert gas. So these elements here, they are all divided among the 3 types of the elements, which are the metals, the non-metals, and the inert gases. So here we know that sodium, magnesium, and aluminium are the metallic elements, and we know what happens in metallic elements. They usually lose electrons to form a compound. So silicon, which behaves as a metal and non-metal, it means it is in between a metal and non-metallic, a metallic and non-metallic properties. So phosphorus, sulfur, chlorine are non-metallic, while argon is an inert gas. So for those ones which are non-metallic, they behave by gaining electrons to form a compound, while argon is an inert gas, and inert gas, it normally have the electrons in their atmosphere cell is full. So it means it neither gains nor lose electrons. So here we shall say that this actually shows that the first 3 elements, because they are metallic, they have bright luster. The 3 elements, which are sodium, magnesium, and aluminium, they have bright luster. And here it means they glitters because they are having the metallic properties. So here we shall say that they glitters. That is why it is known as having the bright luster, and they are easily to cut. You can easily cut the metallic elements. The second element, or the fourth one, which is silicon atoms. This silicon atom, because it is behaving as a metal, as non-metal, is much harder to show its properties, because it has the property of a metal and it also has the property of a non-metal. So, but we can say that silicon, which is much harder than the first elements, which is magnesium and aluminium. So because here it has the two physical properties or a physical appearance, that make it to be much harder than aluminium and magnesium. So here we shall say that phosphorus is a waxy solid. It means here phosphorus, among the three elements which are non-metallics, it is waxy solid, and it is a distinctly non-metallic in appearance. So it has different colors. It can have white color, brownish color, or it can have a red color. So we call each of them by their colors. We can say white phosphorus, we can say brown phosphorus, we can say also red phosphorus. So chlorine and argon are gaseous in nature. So it means that here we can see that the two elements, or the last two elements in this period, is gaseous in nature. So here we can also continue by saying that the melting points and the boiling points of these elements, what happened to their melting and boiling points. So because they are having different types of the elements, that is metal, non-metal, and inert gas, their boiling points varies. But we are going to see that sodium, magnesium, and aluminium have giant metallic structure, because the first elements have giant metallic structure which are maintained by a strong metallic bonds. So we say the boiling and melting points. So we have to know that the first elements, which are sodium, magnesium, and aluminium, are metallic and have a giant structure. So it means their structure is very strong. That makes them to behave like a crystals. So here we mean which this giant structure, or this giant metallic structure of the three elements, are actually bounded by what is known as a strong metallic bond. So here the bond between this element is actually known as the metallic bond. That makes them to have a very rigid structure, or giant structure, which is more or less like crystals. So that is a metallic bond that bind the three elements, that bind the structure of these three elements, and make them to have a giant structure, solid structure. So we said here that the most important thing is the metallic bond that bind these elements together to make them having the giant structure. So we also say that the metallic bond becomes stronger as the valence electrons per atom increase, and also the increase overall nuclear charge, pulling strongly the valence electrons. So the metallic bond becomes stronger as we add more electrons to the outermost shells. So it becomes the metallic bond becomes stronger as there is addition of electrons to the outermost shells of each element. So here we are saying that as we move from sodium to aluminium, we are going to see that the metallic bonds becomes stronger. Why does it become stronger? Because there is addition of electrons into the outermost shells of each element. We know that sodium has a single electron in its outermost cell, while magnesium has 2 electrons in its outermost cell, and aluminium has 3 electrons in its outermost cell. So in this case, we shall say that these elements, the one with the 1 electron, which is sodium, has 1 electron in its outermost cell. It makes it to have a stronger bond, because actually this electron is nearer to the nucleus of the atom of sodium. So we said sodium with this electronic configuration, and we consider this one as a single electron in the outermost cell. So this single electron, it can be pulled into the nucleus of these electrons. So we have the first electrons is 2, 8, and then 1. So this one is much easier to be pulled by the nucleus of sodium atom. So in this case, we shall say that the metallic bonds becomes stronger as the valence electrons per atom increases. So as these electrons increases, it means here we are going to see that the electron in aluminium is having 3 electrons in the outermost shell. So it means that the metallic bond for aluminium is much stronger than the one of sodium, because it is easier to pull the single electrons towards the nucleus. And for the 3 electrons in the outermost cell, it is not much easier than the one of sodium. So it is not easier for the nucleus of aluminium to pull the electrons from the outermost cell to itself. So we call this one as also increased overall nuclear charge, pulling strongly the valence electrons. So here the nuclear charge pulling strongly the valence electrons also increases. So it means the nucleus has to have a very high force that at least it will pull the 3 electrons from the outermost cell, not like the one of sodium. So sodium is much easier to pull, but aluminium, it needs more effort for the nucleus to pull the electrons to itself. So this explains why sodium with the 1 valence electron has a lower boiling and melting point, while aluminium with 3 valence electrons has much higher boiling and melting point. So here it means as we move from sodium to magnesium and then aluminium, so we shall say that this is their outermost shells electrons, which is 1 for sodium, 2 for magnesium, and 3 for aluminium. So as we move downward from sodium to aluminium, or across the period, we shall see that aluminium with the much electrons in the outermost cell is having higher melting and boiling point compared to the one of sodium and magnesium. So what I'm saying is that the metals, they have increasing melting and boiling point. So it means if you move from sodium to aluminium, you will have a higher melting point and boiling points towards aluminium. So if we also see the second elements here, the fourth element, which is silicon. So silicon here is going to behave differently from the three elements, or the first three elements, which is aluminium, sodium, magnesium, and aluminum. So silicon atoms are covalently bonded to 4 other silicon atoms. So actually an atom of silicon behaves by having 4 other silicon atoms, and it will look like this. So we shall have silicon atom and it is bonded to another silicon. So this is how the structure of silicon may behave. So it will have 4 other elements, 4 other atoms of silicon bonded to itself. So in this case, it makes that silicon is a bit having the covalently bonded 4 other silicon atoms. So the covalent bonds are very strong, giving silicon a crystal giant atomic structure, which is more than the one of the first 3 elements, which are sodium, magnesium, and aluminium. So this is bonded by a covalent bond. So this is covalently bonded. So these 4 bonds here are known as covalent bonding, and this gives silicon a giant crystal structure. So here it means as this atom of silicon is bonded by a covalent bond, and to give it this structure of the crystal structure. So a lot of energy is required to break this structure, hence it's having very high melting and boiling point. So for this silicon atom to break, it means it needs much boiling and melting points in order for it to boil or to melt. So in this case, here we shall have much higher melting and boiling point compared to the first 3 elements. So we shall have much higher melting and boiling point. So silicon here, because it is covalently bonded to 4 other silicon atoms, it needs much higher melting and boiling points, and this is actually brought about with the covalent bond. So here it means it has to break all the 4 other bonds or the covalent bond, and then this causes the melting point and the boiling points become much harder compared to the first 3 elements. So phosphorus, sulfur, and chlorine, which are the 3 elements or the 3 non-metallic elements, are made up of simple molecular structure. So the structures here are not like the one of silicon. So it has a much simpler molecular structure. So the atoms of these elements are joined together by a strong covalent bond. Although they have simple molecular structure, but they are still bonded together or joined together by a strong covalent bond to form discrete molecules. So we have to put it by saying that phosphorus, sulfur, and chlorine are non-metallic elements. So here, because they are non-metallic elements, remember that non-metallic elements, they are named so because they gain electrons to fill up their outmost cells. So here, these metals or these non-metallic elements are made up of simple molecular structures. So their structure are made up of simple molecular structure, simple molecular structure. So here it means it is not like giant structures of the first 3 or 4 elements, which are sodium, magnesium, and aluminium. So we shall say that this is also covalently bonded, but the covalent bond is much stronger compared to the one of silicon. So it has a stronger covalent bond, which is known as the van der Waals force. So we shall say that here we are going to have this structure as having a force known as, it is joined by a van der Waals force. Van der Waals force. This is a force which is actually experienced by most metallic elements. So therefore resulting into their general lower melting and boiling point. So here we have to remember that this is making these 3 elements to have a lower melting and boiling point compared to the 4 previous elements, which are sodium, magnesium, and aluminium. So they have lower, in general they have lower melting and boiling points. Melting and boiling points compared to the first 4 elements. So here they have discrete molecules which are held together by the van der Waals force, therefore resulting into their lower melting and boiling point. So sulfur has a higher melting and boiling point than the rest of the nonmetals in period 3. So here we have to have an exception whereby sulfur, although they all have a lower melting and boiling point compared to the rest of the elements, but sulfur has much higher melting and boiling point compared to phosphorus and chlorine. So we shall say that sulfur has much higher melting and boiling points. Melting and boiling points compared to the rest of the non-metals. So the rest of the non-metals are sodium, sulfur, phosphorus, and chlorine. So this is because sulfur exists as having 8 molecules. So we shall have to know that sulfur has these molecules, discrete molecules, which are consisting of 8 molecules of sulfur bonded together. So here we shall say that sulfur is followed by phosphorus, and we shall have phosphorus with the 4 molecules or 4 atoms of phosphorus bonded together to form a discrete structure, then followed by chlorine. So here chlorine is having 2 atoms of chlorine bonded together to form chlorine molecules, while argon exists as a single element, and these individual elements here, because they are known as what? They are known as inert gases, and their outmost cells are already filled and they cannot bind with any other element or with itself. So here we shall have that this decreases as the size of the molecules decreases. So here we shall say that sulfur is having higher melting and boiling point compared to phosphorus, and this is much higher compared to chlorine, and the last one is argon with the lowest melting and boiling points. So we shall also say that there is what is known as the atomic radius. The atomic radius of these elements, atomic radius. So this is another physical property which is known as atomic radius. So atomic radius here generally it decreases from the left to the right. It means from left to the right, starting from sodium, and then it goes to argon. So here we have sodium. Here the atomic radius decreases as we move from sodium to argon. So we know that there is magnesium, aluminium, we have silicon, phosphorus, sulfur, chlorine. So this, as we go from sodium to argon, the atomic radius decreases. So why makes this atomic radius to decrease? It decreases due to the increase in the atomic number. So we need to remember that the atomic radius, boiling points, and the appearance of all these elements are considered to be part of the physical properties of the period 3 in periodic table. So we need to remember what happened when we move from sodium to argon, what happened with its radius, what happened with its melting and boiling point, and also what is their physical appearance. So learners, with this you now know how to distinguish between the radius of sodium element to argon element as we move from left to the right of the periodic table. So thank you very much until we meet next